minus x minus 2, right? I mean, this is top y minus bottom y. That's true, I could do that. But then the thing is, to actually calculate that, we're going to have to break into cases, right? Unless you remember my super snazzy antiderivative for the absolute value function, right? But I'm going to forget that I know that for a second here. So, wait a minute, what are the points of intersection? Can you guys help me figure out those? What are they? We're looking for, what's that? 1? Negative 1, 1. Oh, that's not vertical. That's just a bad drawing. We got to solve the absolute value of x equal to, x squared minus x minus 2 to find the points of intersection, right? The natural enemy to the absolute value function is the square. Oh. Oof. Yeah. I don't know, guys. Like, there's two different ways to go here. To solve this equation, on the one hand, we could square it. But when I do that, that leads us to a quartic. And then we have to factor the quartic. That seems unpleasant. Perhaps a better course of action here is to divide and conquer. So this is either going to give us x less than 0, and the solution must solve minus x is equal to x squared minus x minus 2, right? Or, if x is greater than 0, we're up against x is equal to x squared minus x minus 2. I think that is an easier path than squaring and then trying to factor the quartic. So, but keep in mind, we're going to get extraneous solutions, right? So we got like x squared minus 2 equals to 0. So x is equal to plus or minus the square root of 2 for this side. And on the other side, we've got x squared minus 2x minus 2 equals to 0, which gives us x minus 1 squared minus 3 equals to 0, which gives me x is equal to 1 plus or minus the square root of 3. However, which of these do we keep? I got 4 solutions. Are there 4 points of intersection? Nah, there are not. So the ones we want, context, right? X is less than 0. So we choose the x equals minus root 2 for that one. And here x is positive, so we choose 1 plus the square root of 3 for that. So there you go. This point of intersection is at x equals to minus root 2. This guy up here is actually at 1 plus the square root of 3. And so to calculate the area, what do? Area equals the integral. And so I'm going to break the integral up into 2 pieces. Do you see why I'm going to do that? Because we have absolute value of x, right? So either absolute value of x is minus x for negative, or it's x for positive. So we might as well just break the integral into 2 pieces. So we've got integral from like minus the square root of 2 to 0. Think about this. When absolute value of x is equal to minus x, what happens here? These two, see that? These guys, they just cancel out. And we're just left with 2 minus x squared, yeah? And then we've got plus the integral from 0 to 1 plus the square root of 3 times what? Well, times 2 plus 2x minus x squared dx. All right? Does this make sense? I mean, we think. Yeah?
It does. That's probably the type of process.
Okay, okay. I mean, if there is a particular sticking point, we can talk more about it. That's fine, you know? I was awful tempted to square that top equation, but I realized that would have led us to a bad, bad place. I mean, I don't know. Well, maybe not that bad. Oh no, I'm going to stop. We found our solutions. We don't have to find other way to do it, right? One way to do it's enough, right? Can you do this integral? Can you do these integrals, rather? So they're not too bad, really. We've got 2x minus x cubed over 3. Evaluate that from minus root 2 to 0. And then you've got plus parentheses 2x plus x squared minus 1/3 x cubed, evaluated from 0 to 1 plus squared 3. And so that gives us quiet. Well, fine, I'll accept my... I guess that's far enough. That's far enough. We'll stop there. I do, generally speaking, want you to finish the integration on the test, though. So, like, don't take this as like a license to not finish the work, you know? I got a thing to turn back to you guys, so let me do that.